In December of 1941, a supervisory figure at the esteemed Ford Motor Company's River Rouge facility in Dearborn, Michigan, found himself poring over engineering schematics that were utterly baffling. Instead of the familiar specifications for a V8 engine block, his gaze fell upon intricate technical drawings depicting a formidable 30-ton armored behemoth equipped with a potent 75mm cannon. The devastating attack on Pearl Harbor had occurred mere days prior, and the American federal government had issued an unequivocal directive. The very production lines that had, until recently, busily manufactured civilian sedans and elegant coupes were now mandated to commence the fabrication of military tanks with immediate urgency. This represented no measured incremental shift. Rather, it was an abrupt and seismic transformation. The Automotive Council for War Production, an entity established in the nascent months of 1942, conveyed to Detroit's triumvirate of major automakers, Ford, Chrysler, and General Motors, that the manufacturing of all civilian vehicles would be completely halted by February 1942. This provided an astonishingly tight 2-month time frame for these industrial giants to comprehensively reconfigure their vast manufacturing plants, facilities valued at hundreds of millions of dollars. The groundbreaking ceremony for Chrysler's dedicated tank arsenal, situated in Warren, Michigan, took place in September 1940, notably preceding America's formal entry into the global conflict. This expansive complex sprawled across 113 acres of what was previously agricultural land. With remarkable efficiency, by January 1942, the inaugural M3 Grant medium tanks were already emerging from the very assembly lines where, just a few months prior, Dodge brand trucks had been routinely put together. The rationale underpinning this significant transition from automotive manufacturing to the production of weaponry was remarkably clear and uncomplicated. Automobile producers inherently possessed the trio of essential elements indispensable for the large-scale fabrication of tanks. Firstly, they commanded an immense physical infrastructure, characterized by colossal factory buildings equipped with overhead cranes, sophisticated power systems capable of simultaneously energizing hundreds of intricate machines, and dedicated railway spurs facilitating efficient transportation and logistics. Secondly, these companies possessed an unparalleled mastery of high-volume manufacturing processes, surpassing the capabilities of any conventional armaments firm. While venerable entities such as Krupp in Germany were renowned for constructing superior tanks, their approach was akin to that of skilled artisans, producing items with meticulous, individualized care. In stark contrast, Detroit's industrial philosophy mirrored the flow of a powerful river, continuous, unyielding, and rigorously standardized production. Thirdly, the existing labor force already possessed the requisite expertise in manipulating steel, adeptly operating stamping presses, and precisely integrating thousands of discrete components into a cohesive, operational machine. However, the truly revolutionary aspect of this transformation lay in the fact that automotive plants were not merely adapted for tank production. They were profoundly optimized for it in manners that traditional military arsenals could never hope to achieve. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Please write a comment below about where you are from and what you think about the video topic. The Fisher Body Division, a constituent part of General Motors, which typically specialized in meticulously stamping out automobile body components, was swiftly retasked to become the principal manufacturer of the M4 Sherman tanks' hull sections. Their operational methodology involved treating formidable 5-inch thick armor plate with the identical industrial approach they applied to the thinner sheet metal destined for Buick hoods, as mere raw material to be shaped by colossal hydraulic presses. Bob Gregory, an engineer at Chrysler, subsequently recounted that the most significant hurdle encountered was not the inherent technical intricacy of the various tank components themselves, but rather the considerable effort required to impress upon the workforce that a weld executed on a transmission housing necessitated the same exacting degree of precision as a weld performed on a tank's critical final drive assembly. The sheer velocity of this industrial metamorphosis continues to astound observers, appearing almost beyond the realm of possibility. Chrysler's tank arsenal managed to roll out its initial M3 Lee medium tank in April 1941, an astonishing mere 7 months following the commencement of its construction. Concurrently, Ford's historic Highland Park facility, revered as the birthplace of the iconic Model T, had commenced the production of robust tank engines by March 1942. The entirety of the nation's vast industrial supply chain underwent a profound and rapid reorganization within a span of mere months. Steel mills dramatically altered their rolling schedules to prioritize the fabrication of much thicker armor plate, while rubber manufacturing enterprises reoriented their production capacities toward essential track components for military vehicles. Similarly, electrical manufacturers pivoted their focus, concentrating on the creation of intricate turret motors rather than the familiar car radios. The fundamental element that rendered this ambitious industrial undertaking genuinely feasible was the pervasive application of standardization. The M4 Sherman tank, from its very inception, was conceived with the explicit intention of being mass-produced within existing automotive manufacturing facilities. Its ingenious designers at the Aberdeen Proving Ground engaged in direct consultations with seasoned automotive engineers during 1941, posing a pivotal inquiry that no traditional military procurement officer had ever genuinely contemplated. How can we engineer a tank that is amenable to construction using the established methodologies of car manufacturing? The resultant design solutions encompassed features such as turrets that were bolted rather than welded in the early production models, the widespread incorporation of interchangeable parts across various tank variants, and the deliberate use of engines that could be readily serviced by mechanics already proficient in maintaining trucks. President Franklin Roosevelt grasped a profound truth in 1940, a realization that would ultimately shape the entire course of the impending global conflict. Factories win wars just as surely as soldiers do. On the significant date of December 29, 1940, a full 11 months preceding the attack on Pearl Harbor, he delivered his iconic Arsenal of Democracy fireside chat, reaching an audience of an estimated 60 million radio listeners. This resonant phrase transcended mere rhetorical flourish. It served as a meticulously crafted blueprint for systematically transforming America's formidable industrial capacity into an instrument of war even more potent than any sophisticated bomber aircraft or mighty battleship. Roosevelt articulated production targets that at the time appeared utterly implausible, a staggering 50,000 aircraft annually. Considering that the entirety of the U.S. aviation industry had manufactured only 6,000 planes in 1939, his vision encompassed the production of tanks, naval vessels, and artillery pieces in such overwhelming quantities that they would quite literally inundate the Axis powers under an sheer, insurmountable weight of material. The primary governmental mechanism employed by President Roosevelt to orchestrate this colossal industrial mobilization was the War Production Board, WPB, which was officially instituted in January 1942 and placed under the astute leadership of Donald Nelson, a former Sears executive renowned for his deep comprehension of supply chains and intricate logistics. Nelson's WPB wielded unprecedented authoritarian powers, prerogatives that would have been utterly inconceivable in a peacetime American context. This powerful board possessed the authority to issue mandates compelling any factory to immediately cease the production of civilian commodities. Furthermore, they held the power to meticulously allocate critical raw materials, including steel, aluminum, rubber, and copper, precisely directing which specific industries were to receive designated tonnages. Crucially, they could prioritize government contracts, effectively ensuring that an order for military tanks, for instance, would leapfrog ahead of virtually every other item in the entire national production queue. However, a crucial aspect, often understated or entirely overlooked in many historical accounts and documentaries, is the fact that the government's acquisition and redirection of these vast industrial facilities were not solely achieved through stirring patriotic exhortations. Instead, they strategically deployed pragmatic, compelling financial incentives that rendered wartime production irresistibly lucrative for corporations. The implemented cost-plus contracting system unequivocally guaranteed manufacturers not only the full reimbursement of their production expenditures, but also a predetermined fixed profit margin, typically ranging from 7 to 10%. This innovative arrangement effectively translated into absolutely no financial risk for the participating companies. To illustrate, if Chrysler invested $100 million in constructing and operating a new tank manufacturing plant, the government would meticulously reimburse every single penny of that expenditure and, in addition, provide a profit ranging from $7 million to $10 million. The conventional practice of competitive bidding was entirely suspended. The paramount governmental imperative was the rapid acceleration of production, prioritizing sheer speed over considerations of cost efficiency. Further amplifying these incentives, the Defense Plant Corporation (DPC), a specialized subsidiary operating under the Reconstruction Finance Corporation, provided an astounding $9 billion in financing for the construction of new factory infrastructure between the years 1940 and 1945. Their involvement extended far beyond merely extending loans. The DPC actively constructed entire state-of-the-art facilities and subsequently leased them to private manufacturers for exceptionally modest, often nominal, fees. The Chrysler Tank Arsenal, as a prime illustration, was entirely funded by the government, remained government-owned, and was simply operated by Chrysler. Following the cessation of hostilities, these companies were then afforded the opportunity to acquire these formidable plants at remarkably advantageous bargain prices. This represented a form of corporate welfare on an unprecedented scale, an arrangement that undoubtedly generated significant enthusiasm among industrial enterprises. Notably, General Motors alone secured over $10 billion in war contracts during the period from 1940 to 1945, a sum roughly comparable to an astonishing $180 billion in contemporary currency. The sophisticated intellectual underpinnings informing this comprehensive strategy emerged from the insights of economists who had meticulously analyzed the myriad production failures experienced during World War I. During the 1917–1918 period, the United States had entered that conflict in a disorganized fashion, lacking any cohesive industrial coordination, which regrettably led to widespread shortages, debilitating bottlenecks, and embarrassing profiteering scandals. Bernard Baruch, who had previously helmed President Woodrow Wilson's War Industries Board, offered crucial counsel to Roosevelt, urging him to circumvent these past errors by establishing a system of robust, centralized control from the very outset. Consequently, the War Production Board adopted a proactive stance, not passively awaiting the manifestation of shortages. Instead, they meticulously forecasted national needs up to 2 years in advance and judiciously allocated vital resources in accordance with these projections. The mobilization of the nation's labor force was executed with an equally impressive degree of precision and strategic foresight. The War Manpower Commission, officially inaugurated in April 1942, was endowed with the authority to direct workers into industries deemed essential for the war effort. Unemployment, which had registered at a significant 14.6% in 1940, effectively evaporated by 1943, a testament to the surging demand for industrial labor. Factories that had languished on single shifts during the economic downturn of the 1930s now operated with relentless intensity, running 3 shifts continuously around the clock. To facilitate this unprecedented workforce expansion, the government generously subsidized specialized training programs, expedited 8-week courses designed to impart critical skills such as welding, machining, and assembly to individuals who, in many cases, had never previously entered a factory environment. President Roosevelt's remarkable strategic acumen lay in his profound recognition that the peacetime overcapacity inherent in American industry, specifically the numerous idle factories that were a lingering legacy of the Great Depression, could be ingeniously transformed into a wartime overcapacity, a formidable industrial might precisely aimed at the nation's adversaries. Each M4 Sherman tank that emerged from a creatively repurposed automobile manufacturing plant embodied an immense surge of industrial power that Germany and Japan simply lacked the capacity to equal. Whereas the factories of the Axis powers were already operating at their absolute maximum capacity by 1939, America's industrial potential was, at that point, far from fully realized. The ambitious Willow Run project was widely considered an impossibility. When Charles Sorensen, a pivotal chief lieutenant to Henry Ford, declared in early 1941 that Ford Motor Company intended to construct a factory capable of producing an astounding 1B-24 Liberator bomber every single hour, aviation specialists across the industry reacted with incredulous amusement. Established aerospace giants like Boeing and Consolidated Aircraft manufactured their bombers in limited batches, relying heavily on the meticulous work of highly skilled craftsmen. Sorensen, however, envisioned a production methodology akin to that of the Model T, continuous, high-volume assembly. Time 2s. The monumental facility that ultimately materialized in Ypsilanti Township, Michigan, subsequently served as the foundational template for how America would mass-produce an entire spectrum of military hardware, from sophisticated bombers to robust tanks. Yet, this colossal undertaking almost buckled under the sheer weight of its own audacious ambition. The construction endeavor commenced in April 1941 for what was destined to become the most expansive single manufacturing facility contained beneath one roof, an immense 3.5 million square feet configured in an L shape that extended for over a mile in length and a quarter-mile in width. The mere construction of this gargantuan building necessitated the deployment of 440,000 cubic yards of concrete and an impressive 29,000 tons of structural steel. Ford's visionary engineers meticulously devised a groundbreaking production line where a B-24 bomber would enter as a staggering 450,000 distinct components at one extremity of the factory and emerge as a fully functional aircraft at the other. The entire assembly line progressed at an extraordinarily precise and unwavering tempo, delivering one complete aircraft every 63 minutes. Nevertheless, the profound significance of Willow Run in relation to the production of the Sherman tank lies in this crucial insight. The identical foundational principles of manufacturing were applied to tanks, albeit adapted to different scales of production. While Ford did not undertake the direct construction of Sherman tanks within the Willow Run facility itself, the sophisticated engineering philosophy meticulously refined and perfected. There permeated and influenced the entirety of automotive-based tank production. This philosophy mandated the systematic decomposition of a complex weapon system into manageable subassemblies, the independent construction of each subassembly on its own dedicated production lines, and their subsequent convergence at a final assembly point with unparalleled, almost mathematical, precision. The M4A3 Sherman variant, notably powered by Ford's purpose-built GAA V8 tank engine, served as a quintessential embodiment of this innovative industrial thought process. The initial operational period at Willow Run, which fully exemplified this industrial philosophy, was fraught with catastrophic initial setbacks that almost confirmed the initial doubts of detractors. Upon its inauguration in September 1942, the facility managed to produce a solitary B-24 bomber during that entire month. Workers frequently struggled to locate essential tools, while crucial components arrived out of sequence, leading to persistent interruptions on the assembly line as parts repeatedly failed to fit together correctly. By December 1942, the plant had only completed 56 bombers, a far cry from the ambitious target of one bomber every 60 minutes. The workforce experienced an alarming turnover rate of 50% as employees, frustrated by the chaotic conditions, resigned en masse. Compounding these issues, severe housing shortages forced many workers to sleep in their automobiles or reside in apartments crowded with up to 10 individuals. The pivotal transformation arrived with Charles Sorensen's innovative approach, rooted firmly in established automotive manufacturing principles, an unwavering commitment to standardization, and the extensive deployment of specialized jigs. Every single component was required to fit with absolute precision every time, a demand that necessitated manufacturing tolerances measured in mere thousandths of an inch. To achieve this, Ford engineered an astounding 7,500 distinct jigs, custom-designed fixtures specifically crafted to hold parts in their exact, predetermined positions during critical processes like welding or riveting. Consequently, a complex wing section that previously demanded hours of painstaking assembly by highly skilled craftsmen could now be put together by semi-skilled workers in a matter of minutes, thanks to the guaranteed positioning afforded by these ingenious jigs. This meticulous methodology represented the plant's secret sauce, where traditional aircraft manufacturers historically relied on the individual dexterity and expertise of their workforce to compensate for inherent variations in parts. Ford decisively eliminated the variation itself. This identical jig philosophy proved equally transformative in the production of the Sherman tank. At Chrysler's tank arsenal, the construction of a single hull necessitated 5,000 individual welds. Early production runs were plagued by pervasive quality issues, manifesting as cracking welds, misaligned armor plates, and hatches that failed to seal properly. However, by mid-1942, engineers had successfully developed sophisticated positioning jigs for every major weld point. This innovation meant that workers, even with a mere 8 weeks of training, could consistently produce welds that rigorously met stringent military specifications, precisely because the jigs held every element perfectly square and stable. The tank's fabrication thus evolved from an artisanal metalworking endeavor into a meticulously orchestrated sequence of assembly steps driven by industrial process. By 1944, Willow Run finally achieved its ambitious promise, delivering 1 bomber per hour and occasionally surpassing that impressive rate. The plant ultimately produced 8,685 B-24s between 1942 and 1945, accounting for nearly half of all Liberators ever constructed. This profound lesson, emphasizing that complexity could be conquered through rigorous process engineering, standardization, and the acceptance of building 100 adequate examples before perfecting the 101st, was subsequently adopted across virtually every war production facility. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. In stark contrast, German factories consistently failed to internalize this crucial industrial principle. They stubbornly adhered to a strategy of attempting to construct each individual tank with absolute perfection on the very first attempt. The Sherman tank, on the other hand, was intentionally designed to be merely good enough, a pragmatic approach that exasperated German armored division leaders immensely. When the Panzertruppen first encountered these American tanks in North Africa during late 1942, they observed a striking and unusual characteristic. These American armored vehicles were not engineered to overpower or out-armor their German counterparts. Rather, their strategic objective was simply to out-exist them through sheer numerical superiority. The entire design philosophy of the M4 Sherman revolved around a question that appears strikingly utilitarian, perhaps even pragmatic to a fault. What is the least powerful yet functionally capable tank we can produce in absolutely overwhelming quantities? The choice of engine, in particular, illuminates the entire strategic approach. The original M4 utilized a Continental R975 radial aircraft engine, essentially an aviation power plant bolted into a tank chassis. The rationale for this seemingly unconventional choice was clear. America already possessed the capacity for mass-producing radial engines for its aircraft, and a robust, established supply chain was readily available. Later variants of the Sherman further exemplified this resourcefulness, employing either the Chrysler A57 multibank, which comprised 5 standard automobile power plants connected to a single drive shaft, or Ford's GAA V8, a modified bomber engine. In stark contrast, consider the engines powering German tanks. The formidable Panther, for instance, relied on the Maybach HL230, an engine meticulously engineered solely for armored vehicle applications, demanding highly specific and dedicated production processes. Consequently, when a Maybach engine inevitably failed, it necessitated proprietary Maybach components for repair. Conversely, when a Sherman's engine encountered a malfunction, its commonality often allowed for the salvage of components from standard trucks or other disabled tanks, showcasing a remarkable degree of interchangeability. The selection of the Sherman's 75mm M3 gun underscored an identical design philosophy, being intentionally chosen for its sufficient capability rather than its unparalleled prowess. American ordnance officers in 1941 were keenly aware that the 75mm gun was incapable of piercing the formidable frontal plating of heavier German armored vehicles. However, that was not its primary strategic purpose. The gun's utility lay in its effectiveness in firing high-explosive shells against infantry, its capacity to neutralize medium tanks at reasonable ranges, and, most crucially, the interchangeability of its ammunition with other American military systems. This standardization of ammunition profoundly streamlined the entire logistical apparatus. A single type of 75mm shell could, for example, be effectively utilized by Shermans M3 half-tracks and various towed anti-tank guns, significantly simplifying supply and distribution. Armor thickness further underscores this same narrative of pragmatic design. The Sherman's front hull measured 51mm thick, sloped at a 56-degree angle to achieve an effective thickness of approximately 90mm. German Panthers, by comparison, featured 80mm frontal armor, sloped at 55 degrees, yielding an effective thickness of around 140mm. Superficially, the Sherman appeared significantly outmatched in this regard. However, this represented a fundamental design compromise. Thicker armor inherently demanded heavier suspension systems, more robust engines, broader tracks, and stronger transmissions. The Panther tipped the scales at 45 tons, while the Sherman weighed 33 tons. This 12-ton difference conferred distinct operational benefits upon the Sherman. It could traverse bridges inaccessible to Panthers, be transported on standard Allied flatbed rail cars, consumed less fuel, and was considerably easier to recover when immobilized. The Sherman's transmission achieved renown, though for distinct operational characteristics. It incorporated a synchromesh gearbox, much like those commonly found in civilian trucks. This design allowed drivers to shift gears smoothly without the need for double clutching, thereby reducing both the required training time for crews and the overall mechanical stress on the system. The Panther's transmission, conversely, was infamously delicate and prone to failure, necessitating double clutching and a nuanced understanding of machinery, a mechanical sympathy that poorly trained late-war German crews often lacked. American tank crews could competently operate a Sherman after merely a few weeks of instruction, whereas mastering a Panther demanded months of specialized experience. Maintenance accessibility was an inherent feature of the Sherman, meticulously integrated into every access point and enclosure. A trained crew, using standard tools, could remove the Sherman's engine in approximately 2 hours. The entire transmission could be extracted for repair in a field workshop within a single day. German tanks, particularly the formidable Tigers and Panthers, often required the laborious removal of adjacent systems and structures merely to reach the problem area. A thrown track on a Sherman could be repaired by a single crew in roughly 30 minutes. A thrown track on a Tiger, however, could render the armored vehicle inoperable for extended periods, sometimes necessitating specialized recovery vehicles. This approach was not indicative of a deficiency in American technical prowess. Rather, it represented a profound aptitude for industrial-scale military production, a true engineering genius applied to the demands of total warfare. The visionary designers at Aberdeen Proving Ground consciously posed a critical strategic question. Which factor is more decisive in achieving victory? A small contingent of highly superior tanks or a vastly larger force of merely adequate ones. Their definitive choice was the latter. Consequently, they engineered a tank that automobile factories, with their existing infrastructure and expertise, could realistically manufacture in such prodigious quantities. While the Germans meticulously crafted intricate masterpieces of engineering, America, in contrast, conceived and produced utilitarian, mass-producible widgets. The production figures themselves are truly staggering, almost incomprehensible. Between February 1942 and July 1945, American factories collectively produced an astonishing 49,234 Sherman tanks across all their variants. Consider the profound implications of this figure for a moment. Nearly 50,000 complete tanks manufactured in approximately 3.5 years. This translates to an average output of 1,172 Shermans per month, or roughly 39 units daily, uninterrupted day after day, for the duration of the conflict. In stark contrast, consider Germany's production of its two most formidable and widely recognized armored vehicles. Approximately 6,000 Panthers were built between January 1943 and April 1945, and roughly 1,250 Tiger I and Tiger II models combined were produced throughout the entirety of the war. Germany's total production of all tank types from 1939 to 1945 amounted to approximately 67,000 vehicles. America, astonishingly, produced more Shermans alone than Germany produced Tigers and Panthers combined, exceeding it by an astonishing eightfold. An examination of peak production months further underscored the profound chasm in industrial output. In December 1943, American factories completed 2,200 Sherman tanks. This remarkable rate meant that one Sherman was emerging from an assembly plant somewhere in America every 17 minutes, continuously 24 hours a day for the entire month. The Chrysler tank arsenal in Warren, Michigan alone produced 1,413 tanks between 1940 and 1945, a figure that surpassed Germany's entire Panther production. The Fisher Body Tank Division of General Motors built 11,152 M4A2 variants. Ford's facility added several thousand additional units of the M4A3 model, equipped with a GAA engine. Even the Lima Locomotive Works in Ohio, primarily known for its railway rolling stock, contributed significantly by building 1,650 Shermans. German production, conversely, reached its zenith at a considerably diminished level and with significant chronological delay. The Panther did not even enter production until January 1943, at which juncture America had already manufactured over 10,000 Shermans. Germany's most productive month for Panther output was July 1944, when they completed approximately 380 units. Concurrently, American manufacturing facilities during that identical period produced over 1,600 Shermans. The Tiger Thorn's best production month was April 1944, with a mere 104 units. To put this into perspective, America built more tanks in a single week than Germany produced Tigers in its most prolific month. Why such a profound and overwhelming imbalance? The answer begins with raw industrial capacity. In 1943, the United States produced 85 million tons of steel, whereas Germany produced only 34 million tons. This represented a 2.5 to 1 advantage for America in the essential raw material for tank construction. American aluminum production reached 920,000 tons in 1943, compared to Germany's 250,000 tons, a nearly 4 to 1 advantage in the critical material required for engines and aircraft. The chasm in available resources proved insurmountable. Factory construction timelines uncover a further critical aspect. When America required enhanced tank production, they expeditiously erected additional manufacturing plants. The Grand Blanc tank arsenal in Michigan, operated by Fisher Body, broke ground in January 1942 and delivered its first tank in August 1942. A remarkable 7 months, from initial groundbreaking to operational readiness. This expansive facility covered 1.5 million square feet and incurred a cost of $37 million, financed completely by the state. Germany, however, found itself unable to construct new tank plants in 1943 because relentless Allied bombing campaigns systematically attacked all nascent industrial developments. Consequently, they were forced to fragment their manufacturing operations across numerous suboptimal sites, dispersing production into smaller, less efficient facilities. Germany's aspirations of matching Allied production capacity were severely hampered by a critical scarcity of skilled labor, particularly when contrasted with the prodigious output of American industrial facilities. By 1943, American tank manufacturing plants alone boasted a workforce exceeding 100,000 individuals, a significant portion of whom were women courageously venturing into heavy industrial roles for the very first time. Conversely, the German war machine wrestled with persistent deficits in trained personnel, increasingly resorting to the exploitation of forced labor and prisoners from concentration camps. Predictably, the output from these subjugated workers was characterized by abysmal productivity and flagrant quality control issues. This stark divergence meant that a Sherman tank, meticulously assembled by a well-trained American artisan in Detroit, exhibited consistent and reliable quality, whereas a Panther tank, cobbled together by a starving French prisoner in 1944, often harbored critical, potentially fatal defects. The underlying strategic calculus of the conflict proved relentlessly unforgiving. Even in scenarios where German tanks hypothetically achieved a 3-to-1 kill ratio against their Sherman counterparts, a feat rarely accomplished in the harsh realities of actual combat, the United States possessed the immense industrial capability to absorb the loss of 3 Shermans for every Panther destroyed, thereby maintaining an undeniable numerical superiority. Germany, in stark contrast, simply could not sustain any significant losses. By the middle of 1944, American factories were not merely producing tanks. They were replacing Sherman losses at a pace that far outstripped the German military's ability to destroy them. The cumulative effect of this overwhelming production advantage transformed the war into an intractable equation, one which Germany found itself utterly incapable of solving. The sophisticated assembly line methodologies deployed in the construction of Sherman tanks were, in essence, an advanced and intensified application of Henry Ford. Pioneering Model T principles, integrated with the complex demands of welded armor fabrication. To step onto the factory floor of the Chrysler tank arsenal in Warren during the pivotal year of 1943 was to witness not merely traditional weapons manufacturing, but a meticulously orchestrated industrial ballet, a symphony of synchronized processes and movements. We kindly invite you to stay with us and watch the end of this video. Your like and subscription would be greatly appreciated. Please also leave a comment below, telling us where you are from and what your thoughts are on the topic discussed in this video. The foundational stage of the hull's construction commenced with robust 5-inch thick flat steel plates, which arrived from specialized steel mills already precisely cut to exact specifications. These formidable plates were then transported to powerful stamping presses, machines capable of exerting an astonishing 2,000 tons of pressure, bending solid steel with the apparent ease of mere sheet metal. The operative of such a press was not engaged in traditional craftsmanship. Their role involved the meticulous monitoring of gauges and the precise actuation of levers at predetermined intervals. In this highly efficient system, subassembly emerged as the paramount organizational principle. Rather than adhering to the conventional method of constructing a tank sequentially from front to back within a single stationary location, the Shermans' production was ingeniously fragmented and executed in parallel across numerous dedicated production lines. One specialized team would meticulously assemble the transmission unit, while concurrently another dedicated group fabricated the intricate turret basket. A third team was responsible for constructing the suspension bogies, and yet another focused on the precise assembly of the engine compartment. Each of these completed subassemblies was then efficiently transported either via overhead conveyor systems or rolling platforms to the main assembly line, where all the disparate components converged. This innovative parallel workflow ensured that no single group was left idly waiting for another to complete its task. Instead, all teams worked simultaneously on various tanks, each at different stages of completion, fostering an uninterrupted flow of production. The welding operation, in particular, stood as a testament to how automotive production philosophies profoundly revolutionized tank manufacturing. A single Sherman hull necessitated approximately 5,000 distinct welds to securely join all its armor plates. While traditional shipyard or arsenal welding relied on highly skilled, versatile welders capable of executing any joint at any angle, Chrysler ingeniously categorized these 5,000 welds into specialized types: flat welds, corner welds, overhead welds, and so forth. Workers were then rigorously trained to specialize in mastering just one specific type of weld. Consequently, a specialist in flat welds might execute the very same weld 200 times within a single shift, achieving an unparalleled level of speed and consistency that a generalist welder simply could not replicate. The strategic deployment of jigs and fixtures completely eliminated any element of guesswork from the assembly process. The base of the lower hull, for instance, rested securely within a massive steel fixture meticulously designed to hold the floor plate, side plates, and sponsons in absolute exact alignment as welders performed their tasks. These fixtures were engineered with an astonishing precision, accurate to within 1/32 of an inch. Workers were thus liberated from the need to manually measure angles or verify alignment. The sophisticated jig automatically ensured this critical precision. This ingenious approach enabled Chrysler to recruit and train welders in a remarkably brief period of just 6 to 8 weeks. A stark contrast to the multi-year apprenticeships traditionally demanded by German manufacturing firms. By 1943, the average tank welder employed at Chrysler had been in civilian life just 90 days prior, highlighting the extraordinary rapidity of their integration into the industrial workforce. The intricate turret assembly process unfolded on specially designed rotating pedestals, which afforded complete and unobstructed access to all sides of the component, without the need for manual repositioning. Workers systematically installed the gun mantlet, precisely mounted the formidable 75mm cannon, fitted the intricate recoil mechanism, meticulously installed the gunner's periscope, and connected the traverse motors, all while the turret slowly rotated on its powered stands. This highly efficient, station-based methodology ensured that each worker remained in a fixed location, with all their necessary tools immediately at hand. There was no time wasted traversing back and forth to tool cribs or fruitlessly searching for parts. Instead, all required materials and components flowed seamlessly to their designated workstation. Final assembly represented the ultimate convergence point of this highly streamlined process. The completed hull arrived precisely on rails, while overhead cranes meticulously lowered the engine and transmission, pre-mated as a single, cohesive unit. 4 skilled workers expertly guided this power pack into its exact position, while other teams simultaneously installed the drive shaft. The entire complex power pack installation process was completed in a mere 45 minutes. This stands in stark contrast to German tank plants, where engine installation was typically an all-day affair, necessitating extensive custom fitting and adjustments. Next, the fully equipped turret, already complete with its gun, ammunition racks, radios, and crew stations, was precisely dropped onto the hull ring. The entirety of the final assembly process, from a bare hull to a fully operational running tank, took approximately 8 hours. Crucially, quality control was embedded at each individual station, rather than being relegated solely to the final stages of production. Inspectors, equipped with precise go-no-go gauges, continuously checked welds. If a weld failed inspection, the worker responsible immediately redid it, preventing the defect from progressing to subsequent stations. This proactive approach ensured that defects were identified and rectified early in the production cycle, when they were significantly less costly to fix. By the time a Sherman tank finally reached the test track, it had already undergone dozens of rigorous inspections. The German method, conversely, involved inspecting completed tanks, often necessitating extensive disassembly to rectify identified problems, a process that proved catastrophically inefficient. The remarkable individuals who ultimately constructed the monumental fleet of 49,000 Sherman tanks were not the workforce anyone might have anticipated at the outset of the war. In 1940, American factories were predominantly staffed by white men, many of whom were immigrants or the sons of immigrants, possessing industrial experience passed down through generations. However, by 1943, the composition of tank plants had undergone a radical transformation. Women constituted an extraordinary 40% of the workforce at Chrysler's tank arsenal. African Americans began to occupy positions previously exclusively reserved for white workers, and even elderly individuals who had retired years earlier returned to the production lines to contribute to the war effort. This demographic upheaval on American factory floors proved to be as profoundly revolutionary as the sheer production numbers themselves. The iconic figure of Rosie the Riveter was not merely a piece of wartime propaganda. She represented a compelling statistical reality. Women entered heavy manufacturing sectors in unprecedented numbers, primarily due to the massive exodus of men into military service. Between 1941 and 1945, the military drafted a staggering 16 million Americans, creating severe labor shortages that would have crippled industrial production had it not been for the crucial intervention of women who stepped in to fill these critical gaps. At the Fisher Tank Arsenal in Grand Blanc, Michigan, for instance, women were operating 20-ton overhead cranes, running powerful stamping presses, and performing intricate welding tasks on armor plate. These were decidedly not light assembly jobs. They were physically demanding and inherently dangerous positions that required significant lifting, climbing, and working with heavy and perilous equipment. The training programs established during this period were remarkable for their exceptional efficiency and brevity. The War Manpower Commission played a pivotal role, establishing extensive engineering, science, and management war training programs across universities and vocational schools nationwide. A typical welding course, for example, ran for an intensive 6 weeks, with students attending 6 days per week, 8 hours per day. Trainees practiced relentlessly on scrap steel until they could consistently produce flawless welds, after which they graduated directly to the factory floors. Machine operation training followed a similar accelerated model, involving 4 to 8 weeks of intensive instruction on essential equipment such as lathes, milling machines, or drill presses. The long-held notion that skilled manufacturing demanded years of traditional apprenticeship simply evaporated under the pressing exigencies of wartime necessity. Production shifts operated around the clock, organized into 3 continuous 8-hour rotations. The first shift commenced at 7 a.m., the second at 3 p.m., and the third, the graveyard shift, began at 11 p.m. This rigorous schedule ensured the tank plants never ceased operations. When one crew departed, another arrived within minutes to seamlessly take over precisely where the previous shift had concluded. Workers assigned to the third shift earned a 10% differential in pay, though recruitment for the midnight to 8 a.m. slot nevertheless remained a persistent challenge. Factories also provided 24-hour cafeterias, a crucial provision stemming from the recognition that fatigued and hungry workers were prone to making costly mistakes that could potentially ruin a tank hull worth thousands of dollars. Housing swiftly emerged as a major crisis. Chrysler's tank arsenal alone employed 25,000 workers at its peak production. Yet Warren, Michigan was not a municipality equipped to accommodate such an enormous and sudden population surge. In response, the Federal Public Housing Authority rapidly constructed emergency housing projects, including basic apartments and dormitories, which were erected within a matter of months. The Willow Run Housing Project, situated near Ford SS Bomber Plant, gained considerable notoriety for its 3,000 trailers and temporary housing units, often crammed into muddy fields. Workers frequently shared bedrooms on opposing shifts, a practice known as hot bunking, borrowed from naval tradition, where one worker slept while their counterpart was at work. Wages, while considered good by the standards of the Great Depression era, were by no means extravagant. A tank welder in 1943 typically earned approximately 90 cents per hour, amounting to about $37 for a standard 40-hour week, augmented by overtime pay. This sum, roughly equivalent to $650 per week in 2025, represented a solid middle-class income. However, women frequently earned less than men for performing identical work, typically receiving 60–70% of male wages. Though this disparity actually marked an improvement from pre-war conditions. African American workers faced similar wage discrimination and were often assigned the most arduous, dirtiest, and dangerous jobs such as foundry work, sandblasting, and heavy lifting. Workplace injuries were regrettably common and often severe, as metalworking is an inherently hazardous industry involving moving machinery, heavy components, molten welding slag, and overhead cranes maneuvering multi-ton loads. The Bureau of Labor Statistics recorded a tragic toll of over 37,000 workplace fatalities in American factories between 1942 and 1945. The industrial complexes dedicated to tank manufacturing experienced an elevated incidence of workplace injuries, a direct consequence of handling the immense weight and sheer scale of the constituent parts. For instance, the catastrophic descent of a heavy armor plate could tragically result in a worker's instantaneous demise. Furthermore, the intricate process of welding within the constricted confines of a tank hull frequently exposed laborers to severe burns and noxious fumes, presenting constant hazards to their health and safety. Despite these perilous conditions, the rate of employee attrition at these vital facilities remained remarkably modest after an initial probationary period of approximately 3 months. This notable stability was forged by a powerful confluence of factors: an unwavering sense of patriotic duty, the assurance of consistent wages, and the robust camaraderie that developed among the workforce. These diligent individuals were profoundly aware that their strenuous efforts carried significant weight, understanding that each Sherman tank emerging from the assembly line potentially symbolized the safe return of their sons, brothers, and husbands from the battlefront. It is a profound historical truth, not a mere rhetorical flourish, that the ultimate defeat of Germany in World War II was, in essence, predetermined within the bustling factories of American industrial hubs such as Detroit, Warren, and Grand Blanc, long before any Sherman tank engaged in actual combat. This assertion is not an exaggeration, but rather a stark reality, rooted in the incontrovertible principles of mathematical calculation and overwhelming productive capacity. As the war progressed into 1944, the formidable German Wehrmacht found itself confronted by an insurmountable strategic dilemma, an equation that defied any viable solution. While their armored vehicles often boasted qualitative superiority in one-on-one engagements, their tank crews possessed a deeper reservoir of combat experience, and their tactical doctrines had been meticulously honed over years of intense warfare. These advantages proved ultimately inconsequential. The reason for this stark reality was that they were being inexorably overwhelmed, buried beneath a relentless deluge and veritable avalanche of American armored vehicles. This torrent of steel arrived on the battlefields at a pace that far outstripped the German forces' capacity to neutralize or destroy them. The stark narrative of material attrition, therefore, illuminates the true story of the conflict with an unforgiving and brutal clarity, demonstrating that sheer quantity could trump individual quality. Please stay with us and watch the end of this video for the full story. We would be incredibly grateful for your like and subscription. Also, we invite you to share in the comments where you are from and what your thoughts are on this compelling topic. A vivid illustration of this dynamic unfolded during Operation Cobra, the pivotal American breakout from Normandy in late July 1944, which commenced with an initial offensive involving approximately 1,500 Sherman tanks. Within the first week of fierce combat, German forces managed to incapacitate or destroy around 300 of these American armored vehicles. This represented a substantial 20% loss rate, a figure that might initially appear catastrophic and strategically crippling. However, this perception quickly dissipates upon considering that American supply depots strategically located in England were able to dispatch an immediate shipment of 450 replacement Shermans directly to France. Consequently, the U.S. Third Army, under the command of General Patton, not only maintained its relentless advance, but, astonishingly, accelerated its operational tempo. In stark contrast, German panzer divisions found themselves utterly incapable of replenishing their losses. A Panther tank rendered inoperable or destroyed in the Normandy theater was, for all practical purposes, permanently removed from the conflict. While German manufacturing facilities might eventually produce a replacement unit, the formidable challenge of transporting it to the front lines in France navigating through overwhelming Allied air superiority rendered such an endeavor almost entirely unfeasible. It was unequivocally in the critical domain of logistics that the immense industrial might of America truly exerted its suffocating pressure upon Germany's war machine. A single Sherman tank, for instance, had a voracious appetite, consuming approximately 150 gallons of fuel for every 100 miles it traversed. When one extrapolates this prodigious consumption across thousands of active tanks, the profound strategic significance of the U.S. petroleum industry becomes strikingly clear. In 1944 alone, American oil producers churned out an astonishing 1.5 billion barrels of crude oil, a volume that surpassed the combined output of all other belligerent nations. Germany, by contrast, managed to produce a mere 40 million barrels in that same year, with the majority derived from synthetic processes utilizing coal. When formidable Allied bomber formations systematically targeted and devastated German synthetic fuel plants in mid-1944, the consequences for the Wehrmacht were immediate and dire. Panzer divisions found themselves quite literally immobilized, devoid of the necessary gasoline to operate. This critical vulnerability was starkly highlighted during the Ardennes Offensive in December 1944, famously known as the Battle of the Bulge, an operation fundamentally predicated on the desperate hope that German forces could seize American fuel depots, as they simply possessed insufficient fuel reserves to sustain the ambitious offensive to its intended conclusion. The relentless scarcity of spare parts proved to be as devastating to German operational readiness as direct combat losses, effectively crippling their armored forces from within. Should a Sherman tank experience a mechanical issue, such as a thrown track or a damaged transmission, the necessary replacement components were swiftly dispatched, often arriving within a matter of days from vast supply depots brimming with thousands of standardized parts. In stark contrast, German tanks suffered from persistent mechanical failures. The final drive mechanism of the vaunted Panther tank, for example, was infamously delicate, prone to failure on average every 150 kilometers in its initial production variants. Crucially, however, replacement final drives were never available in adequate quantities to meet demand. Consequently, German units frequently reported a staggering 30 to 50% of their tanks as non-operational, not due to battle damage, but because of mechanical breakdowns. This dire situation compelled them to resort to cannibalizing parts from damaged or derelict tanks in a desperate attempt to keep other vehicles running. A grim death spiral that inevitably ensured a continuous and irreversible decline in their overall operational strength and combat effectiveness. The robust and extensive training infrastructure in the United States unveiled yet another critical facet of American industrial and logistical supremacy. Dedicated U.S. Time, TWOs, tank training schools, prominently located at Fort Knox and Fort Benning, consistently graduated thousands of fully qualified crews on an annual basis. Each of these trainees underwent a comprehensive and rigorous instructional period lasting between 12 to 16 weeks, ensuring a high standard of proficiency. This formidable capacity meant that for every Sherman tank crew tragically lost in combat, an astonishing 5 thoroughly trained replacement crews were readily available within the continental United States, prepared to be deployed. Conversely, by 1944, Germany's once vaunted military training pipeline had suffered a catastrophic collapse, unable to sustain the demands of total war. Replacement crews were forced to contend with mere weeks of instruction, a drastic reduction from the months of thorough preparation their predecessors had received. Often these hastily trained soldiers would not even lay eyes on the specific tank model they were assigned to operate in combat until their arrival at the volatile front lines. This critical lack of hands-on experience and comprehensive training among new crews served to exacerbate the inherent mechanical unreliability of German armored vehicles. Their unfamiliarity with the intricate operational procedures of complex systems inevitably led to an increased frequency of breakdowns, and tragically, a higher incidence of combat losses, further eroding the Wehrmacht's fighting capability. The strategic bombing campaign, a monumental undertaking made possible by the prodigious output of American industry, ultimately served to complete the intricate loop of German destruction. The very same factories that were churning out thousands of Sherman tanks were simultaneously constructing B-17s and B-24s, the formidable heavy bombers that systematically dismantled German industrial capacity from 1943 onwards. Key targets included the vital ball-bearing plants at Schweinfurt, the crucial synthetic oil facilities in the industrial heartland of the Ruhr, and the extensive locomotive works essential for moving supplies across the Reich. These specific objectives were chosen with meticulous precision because American intelligence had astutely recognized that Germany's war economy lacked the inherent resilience and redundant capacity to absorb such widespread disruption, unlike the robust and expansive industrial base of the United States. When Allied bombs irrevocably destroyed a German tank factory, it typically remained in ruins, its productive capacity permanently extinguished. In stark contrast, America possessed the unparalleled ability to endure the loss of an entire manufacturing plant and simply erect another or shift production, demonstrating an almost limitless capacity for regeneration. The ultimate statistical summation of this industrial contest presents a stark and undeniable reality. Germany, throughout the conflict, managed to produce approximately 25,000 units of its most formidable armored vehicles, the Panthers and Tigers, combined. In stunning contrast, America's factories yielded a staggering 49,000 Sherman tanks within the same period. This numerical superiority was merely the tip of the iceberg, as the United States also manufactured an additional 24,000 light tanks, 2,400 heavy tanks, an incredible 89,000 aircraft, and 5,000 vital cargo ships during that identical time frame. This industrial output was not merely superior, it was, in its sheer magnitude, existentially overwhelming for the Axis powers. Essentially, Germany waged World War II with the industrial capabilities commensurate with a regional power, while America engaged in the global conflict with the boundless productive capacity of an entire continent. The ultimate outcome of the war, therefore, was cast in stone, and never truly in doubt from the moment those repurposed American automobile plants transitioned their formidable capabilities to the production of tanks and other war materiel.